The board is thick, so it takes a lot of heat. Here we have an EVGA RTX 3090 FTW Ultra that came in for repair. The title on the ticket reads RTX 3090 with red light on. If we go to the description, let's see what the customer wrote. GPU was working great when the computer suddenly crashed and had to be force restarted. Upon restart, the GPU had no video and the red light next to, not above the power connectors, was on. Okay, so the video card is not working and there's a red light that appears next to the power connectors. We already have the motherboard out right here. The board is big, huge. 3 connectors on top. And let's see what's going on. Hopefully it's something that we can fix. We're gonna start with the 3 power connectors, the 12-volt connectors on the top. And we wanna measure for a short. Do we have a short circuit on any one of the 12-volt lines? Before we start the video, I want to give a shout out to our sponsor PCBWay. PCBWay is a China Shenzhen-based PCB manufacturer and printed circuit board assembler with more than a decade in the field of PCB prototype and fabrication. They offer a wide variety of services including 3D printing, CNC machining, sheet metal fabrication, and much more. PCBWay is committed to meeting all your PCB needs. They offer quality, on-time delivery, and competitive pricing. 1 to 2 layer boards starts at $5 with 24 hours turnaround. Get an instant quote by visiting PCBWay.com or click on the link below and make sure to check them out. We're not going to measure at the connectors, but we're going to measure at either the current sense resistor, the fuse, or the coil. Let's measure at the coil. Meter and diode mode. And if we measure here, we do not have a short. If we measure here, we do not have a short. And if we measure here, 0.48 voltage drop. We do not have a short. What about our fuses? 0.48, 0.48, 0.48 on both sides. And we have 0.48 on both sides. So we do not have a short circuit on any one of the 12-volt lines. Moving a bit down. 0.34, 0.39, and we have 0.36, and going all the way down, right next to the PCIe slot, 0.23, and if we measure our PEX line, we're gonna do it in resistance mode. We should get something around 6 to 8 ohms. I'm reading 6.2 ohms. So based on the readings, our core should be good, but we do not know for sure. We measured good on our 12-volt lines. 5 volts, 1.8 volts, PEX, and memory. If we go down here to the PCIe slot, we're going to measure 12 volts here. Let me go back to diode mode. We do not have a short circuit. And if we measure our 3.3 volt line, we are reading 3.3K. Perfect. No issues at all. All readings are good. So far, so good. Our readings are good. I have not tried the card yet, but before I do, let me quickly go over the card, just quick visual inspection. A lot of times we come across a knocked off component or a blown component or a ripped component or liquid damage or liquid metal. Possibilities are endless. So just a quick visual inspection and we can measure along the way. We already measured this fuse, and this fuse. They're all good. Our 12-volt lines are good. And the board, for the most part, looks clean. We're going to have to figure it out. When I check on those DR MOSFETs, I usually check the pins around just to see if we have any burn marks or we have any solder blob that's bulging out. Let's continue with visual inspection. And we do not have a crack anywhere down here. With this high quality microscope, nothing will go unnoticed. We can see everything, including the texture on that board. Which microscope are you using? I'm using the NorthridgeFix microscope. We have the latest version, the red one. You can log into our site at northridgefix.com, click on shop, and you can buy all your tools from there. This amazing microscope, the articulating arm, anti-glare light, which is currently out of stock, but we should have it in about maybe 3 weeks. The ring light, soldering stations, hot air stations, power supplies, voltage injection tool, Flux, tweezers, braid wick, one of the best braid wicks in the market. If you have purchased a braid wick from us before, you know how good quality that wick is. It's not flimsy and it does not break apart like all the other wicks that you buy. So nothing is obvious as of now. Everything looks clean. Again, we're going to check those DR MOSFETs. Just some dust here. No big deal. Let's flip the board. And we're going to start from the far end. And while at it, why not measure the 0 ohm resistor? It does not hurt to hit 2 birds with 1 stone. And we have 0 ohms. No problem. I'll put the meter in diode mode. We have all caps on the bottom here for the data lines. No problem. And let's go over this fuse here. Meter in diode mode. And what's going on? I'm not reading. Oh, the fuse is blown. If we measure to ground. Oh, short to ground, right here. We have a short to ground. This end is reading OL. And we have a short to ground. Okay, so we got it. That's our culprit. That's the bad guy. Say hello to the bad guy. You see, by just doing a visual inspection, doing some measurements, we got the bad guy quick. Now we're going to handcuff him and take him to jail. So the fuse is blown. But what blew the fuse? The fuse is not going to blow by itself. There's something that caused that fuse to blow. This fuse is linked directly to V-core. So let's hope for the best. One more time. Short to ground, and we are reading OL. And if we measure in continuity mode, OL. The fuse is blown. All right, so how do we figure this out? What we're going to do is use our voltage injection tool, the NF.short. We're going to inject voltage at the bottom side of the fuse, and we're going to monitor the board under a thermal camera and see what gets hot. I want to know what caused that fuse to blow, where the short is coming from. So right now I have the voltage injection tool set at 1.5 volts. I'm going to attach the ground probe onto a metal piece on the video card. And we're going to inject voltage at the fuse. So let's see what happens when we inject voltage at the fuse. 1, 2, and 3. I injected voltage. And I do not see anything hot on the board. Heat may be coming from front of the board and not from the back. Let me see if I can inject voltage and flip the board and hold the thermal camera with my other hand. if we do this, I'm injecting voltage at the fuse, and we're gonna do this. Oh, I see it. I see it. I see it. Let's see if you can figure it out. So that's the beginning of the card right here. We have the connectors down here, 1, 2, and 3. And look at this. Right there, right there, right there. So it's 1, 2, 3, 4, 5. It's DR MOS number 5. Wow. Wow. 1, 2, 3, 4, 5. DR MOS number 5. We got it. So the fuse is not the only bad guy, but we're gonna have to take somebody else to jail. So I counted 5. 1, 2, 3, 4, 5. Right there. That's the bad guy. The heat was coming from this DR MOS. Now, which DR MOS is this? AL00. No problem. We're going to have to apply heat to remove that DR MOS, but we have to be careful because we have aluminum capacitors right on the left. Right on the left. Right, left. We have aluminum capacitors on the left. So we're going to put that piece of heat sink on top here. Apply heat and remove this DR MOS. The area is tight. We have tall inductors, maybe 1/4 of an inch, and we have the aluminum caps on the left. We're almost there. The board is thick, so it takes a lot of heat. It popped. Wow. We're gonna have to replace those 2 caps, this one and this one. You see what happens when you apply a lot of heat? But we do not have an option. The other option would be to preheat the board and then do it that way. I never had issues putting the heatsink over the caps and removing the DR MOS. But what can you do? No problem. That board wanna play games? We can play games. Let's remove the caps and then we'll do it again. So it's cap number which one? 1, 2, 3, 4, 5, 6. Cap number 6. So we have 1, 2, 3, 4, 5, 6. Right there. I always mention aluminum caps to watch out and be careful. We're gonna apply low melt solder. Right, and we should be able to pull that cap from front of the board. Oh, the cap fell. Huh. The cap fell by itself, right there. The magic of low melt solder. We're gonna use our NF dot sucker to remove solder from the holes. Done. 2 strokes. Done. Look at this. One of the best suckers in the market for all the suckers out there. I went over this in a previous video. One of the best in the market. Now I'm thinking, why not remove the other cap? Just take it out of the way so we do not have any issues. This right here. Let's take this guy out so we can clear the way. Like I said, this area is tight. We do not have any room to breathe. And the cap most likely fell on the other side. Yes, right there. Again, we're going to use the NF that sucker. Now I cannot put the sucker vertically under the microscope because I only have like 4 or 5 fingers of room under that microscope. Let me see if I tilt it sideways so I can show you. The sucker must be vertical, but I want to try it sideways, quick. Look at this, wow. That sucker is powerful, very, very powerful. You know how when you shoot a gun, how the gun pulls back? Same thing with this. I press it and I feel like my hand is going up. Let me move the microscope out of the way so I can desolder vertically like this. 1 and 2. 2 strokes, done. Better than factory holes, right? Flip the board, and now we can desolder the armas safely. But still, I want to use that heatsink. Out. Life sentence for that guy. Let's remove the heatsink. Hey, what's up, man?
Oh my goodness.
What's up, buddy? How are you doing?
Thank you so much. Nice
All right.
to meet you. I love your stuff. I found out about you from Louis Rossman, or there's big old, and you have an amazing opinion. I agree. It's
Now we're gonna use our anti-glare light so we can get rid of the reflections. So now that we removed the DR mass, why don't we check and see if the short is gone? The fuse is still blown and we have to replace it, but I just want to make sure that we do not have a short circuit anymore. Meter in diode mode, the meter is off. And do we have a short? We do not. We got it. 0.5 voltage drop, and we're gonna read OL here because the fuse is blown. If that fuse was not blown, then we would read 0.5 volts on either ends of the fuse. So we're gonna have to remove that fuse as well. Why not do it now, since we are already in this area? Ninth dimension. And the fuse is soldered on nicely. And let's go ahead and measure the fuse, make sure it's continuous. Measure in diode mode, we are reading 0.44, the board is still hot. And this side is reading 0.44, 0.443, 0.444. It's gonna go up to about 0.5, but the fuse is continuous, and if we measure from here to here, amazing. Amazing. We are using the NorthridgeFix anti-static brush, Kimtech wipe, 99% isopropyl, and the board is better than factory. Awesome. Very nice. And we are done. I replaced the DR mass, the fuse, and all we have to do is replace the two caps right there. 1 and 2. One of them blew off. And the second one, we're gonna replace it. We have a 270 cap right here. Flip the board, solder the back. And then we're gonna do cap number 2. And then we'll test. Cap number 1 is done, and now we need cap number 2. We can grab one from here. Let's grab this one, the second one from a donor board. And of course, for this one, we're gonna use low melt solder. And we got it. And now we're gonna solder cap number 2. Let's use our anti-glare light. Anti-glare light is awesome. The anti-glare light is currently out of stock. We are expecting a shipment in about 3 weeks. Beautiful. Now all we have to do is test and hope for the best. If the card works, great. It will be a nice end of the day repair. And if it does not work, I'm gonna be mad. I'm gonna be mad and I'm gonna have to revisit tomorrow. So I replaced the two caps right here, 1 and 2. Replaced the DR mass and replaced the fuse right here. Hopefully the cord will work. We're gonna connect the power cables. Cable number 1 right here. Cable number 2. All right. And we have cable number 3. Somebody is calling from an 818 number. I'm not going to answer right now. So we have all 3 connectors in place right here. And we have the PCIe adapter that connects directly with the motherboard. I do not have a fan or heatsink, but that's okay. On most video cards, we should be able to turn the card on for a few seconds. But on some, we need to have the heatsink and fan in order for the card to turn on. I have the HDMI cable connected, and all we have to do is look at the screen here and see if we're gonna get an image. One, 2, and 3. I do see the light on the card. Before, the customer said that he's only seeing a red light at the connector side. But we are seeing lights on the card and the Dell logo. Yes, yes, awesome. The card is working right here. And we are done. Wow. Wow, we did it. Big Boss will reassemble the car tomorrow, test it, invoice, and mail this back to the customer. Wow. Remove the cords, remove the cables, and we're done. I hope you enjoyed the video. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video.